All right, friends, here we go again. We are on 9.7 today, factor special products. Some of us may find this quite easy. Some of us may not. I think once you get the hang of it, you will find it quite easy because the rules are pretty straightforward here. But as I said last time for the video earlier in the week, pretty much same strategy, same processes, same steps, same rules. We're just doing what we call special products here, and I'll show you what I mean. So this time I'm actually going to pull up 3 problems or so from the actual work, so you'll at least have those done. But do track with me so you know which ones we're doing, and so you can see what I'm doing, where I'm getting it from, et cetera, et cetera. So chapter 9, section 7, so 9.7, page 603 is where we are. And as I said, I'm going to be pulling problems straight out of the assignment. So let's start with number 6. Let's do that. So it says factor the polynomial, and the polynomial is 49 minus 121p squared, I think it says. Yep. Okay, so this is different, and this is why it's called a special product. That's why the lesson says factor special products, because there's only one sign here. So some of us may look at this and think, oh, this is going to be easy. Some of us may look at it and think, oh, this is going to be hard. But it's actually quite easy. And the reason I say that is because whenever you see this type of polynomial, it's called a special product. There's only one sign. How do you get, when you multiply, when you're finding products, how do you get a negative number? It's not by multiplying two positives, and it's not by multiplying two negatives. It's by multiplying a positive and a negative. And so that means my signs are automatically going to be a positive and a negative, just like that, okay? And so I'm going to follow the same factoring procedures. I don't have an exponent here. It's not squared. That doesn't mean it's backwards. It's okay. I'm still going to follow the same steps. So let's factor 49. That's 7 and 7. 7 times 7 is 49. Now the difference here, one of the differences that we haven't discussed yet, is that I'm not trying to find 2 numbers that will multiply to give me 49, but add or subtract to give me 121. Again, this is a special product, so it's a little different. So 7 times 7 is 49. And then here I have my exponent, and it's raised to the second power. So let's factor 121. Well, the thing that comes to my mind, first of all, is 11 times 11. So I'm going to, and then this p squared. So I'm going to do 11p. And then I'm just going to multiply that out and see if that works out. 7 times 7 is 49. Now this is why another reason why it's a special product and why it's pretty cool, because 7 times negative 11p is negative 77p, and then positive 11p times 7 is positive 77p, and then 11p times negative 11p is negative 121p squared. And so what you'll notice is these cancel out. When I combine these like terms, they cancel out. That will be the case for every single one of these type of problems. So 49 minus 121p squared, so that is squared, so that is correct. Again, you will notice when you check it, if you check it, that these will cancel out every time. That's why there's only 2 terms there. Okay, so bam, there's your answer. All right, another one, number 11. Let's do number 11. 49a squared plus 14a plus 1. So this one is not a perfect square, as we called it earlier. It has 2 signs, but I'm still going to do the same way I have done it before in days and weeks and lessons past. Bam, same signs, bam, both positive. Factor 49a squared, I'm going to shoot for 7a times 7a, and then, well, that's easy, 1 and 1. Let's see if it works out. 7a times 7a is 49a squared. 7a times, times 1 is 7a. 7a times 1 again is 7a, and then 1 times 1 is 1. That's not, there we go. Okay. So 7a plus 7a is 14a. I just combine like terms there as I usually do. There it is. That matches up. So there's my answer. And when you have 2 of the same exact terms, or the same sets of terms, you can simply, yeah, we're in the camera, 7, you can write it simply as 7a plus 1 squared. And that will suffice. That is actually more algebraically correct. So bam, there it is. And let me do another one, slightly different. I think you're going to find this lesson maybe a little less challenging than the last one or some others past, and that's simply because you're catching on more and you're kind of just building on what we've been doing. So I'm hoping you're experiencing that. But let's look at number 15. 4c squared minus 400. And I picked these three particular problems because they highlight the 3 different types of problems you're going to have during this assignment and moving forward, like on the next quiz. So here, again, it's a perfect square because there's only one sign and it's negative. And as I said, you always think a positive times a negative is a negative. So that's where I'm going with this with the signs. But before I start doing that, I'm going to actually factor out, because I see that these 2 terms have something in common. They have a 4 in common, do they not? I can factor out a 4 out of here, okay? The first example I did, which was number 6, I could not do that for the 49 and the 121. I could not factor any common terms out. Here I can. So just like we did, I think it was last week, 4, and then I'm going to write what's remaining in the parentheses, so c squared, and then I didn't subtract 4, so I'm not going to write 396 right here. I factored a 4 out, so 4 times what will give me the 400? Well, that's going to be 100. So 4 times c squared minus 100. That is not the answer, because now I can factor this. I just simply factored out 1 term. This remains to be factored. All right, so put my 4 out here again, always carry that down, break out my parentheses. Remember, it's a negative, so positive times a negative, c squared, that will leave me with c and c, and then I'm gonna go straight for the 10 times 10 and see what that does for me. C times c is c squared. C times negative 10 is negative 10c. 10 times c is positive 10c, and then 10 times negative 10 is negative 100. As I told you in the first example, negative 10c plus 10c, those cancel out, leaving me with c squared minus 100, which is what I had right there. And just don't forget the 4, of course. So that is my answer. 4 times the quantity c plus 10 times the quantity c minus 10. So all we're doing is those 3 types of problems today, just a variety of them. So if you look in your book, you'll see those on page 603. As I mentioned, I did number 6, number 11, and number 15, I believe it is. Yep. Now, what you'll find is if you do not factor the 4 out first, you won't necessarily get the wrong answer. You'll get an incomplete answer because it will basically shake out to look something like this. We'll do 2c, and then 20 times 20 is 400. So you'll look something like that, but you'll notice that you can still factor out 2's from here, okay? So that's where we got our 4 from before. So don't create more work for yourself, factor it out in the beginning, and then you can go from there, okay? So page 603, let's see, just like I said last time, you'll notice the last set of problems there, 25 through 39, they're set to 0. And so just like we always do, when it's set to 0, you're going to factor it out by putting each set of parentheses equal to 0, and you will get 2 answers, x equals and x equals, or whatever the variable is. So sometimes it'll be the same. Sometimes it'll be like, for example, 4 for each one. It'll be x equals 4, x equals 4. That's okay. Sometimes it'll be x equals 2, x equals negative 2. That's okay. Sometimes it'll be 2 completely different answers, like 0 and 1. That's okay. All right. So just make sure you set both of those sets of parentheses to 0. All right. So if you missed anything or feel like you need to watch it again, please do so. Otherwise, go ahead and get started and let me know if you need any help. And we will talk soon. All right. Thanks again.